Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And remember, take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Greenbelt by Titus, and here are the rules. Normal Sudoku rules apply, which means the digits 1 through 9 each appear exactly once in each row, column, and 3x3 box. German whispers. Adjacent digits along a green line differ by at least 5. So for example, if this were an 8, this would have to be a 1, a 2, or a 3 to be adjacent to it, because you have to have a difference of at least 5 between adjacent digits on a German whisper line. Circles. A digit in a circle indicates exactly how many circles contain that digit. So, for example, if this were a 7, that would mean there are exactly 7 circles which contain a 7 somewhere in this puzzle. So you would have to have 6 other 7s to make this rule work. Similarly, if there was a 3, there would be 2 other 3s, and we would celebrate because a 3 is in the corner, but we would have to have 2 other 3s in circles in this puzzle. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first thing I do in circle puzzles is usually count how many circles there are. How many circles are there? 1, 2, this is 4, so that's 6. This is 2, so that's 8. So 1, 2, 6, 8, 11, 12, 16 for these 4, plus 3 is 19, 19 plus 4 is 23, plus 1 is 24. Okay, so we have 24 circles, I think. Let's count it this way just to double check. 2, 7, 10, 13, 15, 17, 19, 22, 24. Yep, there are 24 digits in this puzzle. Sorry, 24 circles in this puzzle. So therefore, the digits in the circles, the unique digits must add up to 24, right? Because if you have 9 in a circle, that means you have to have 9 circles filled with a 9, right? So each digit matches the number of digits in a circle. And we know, let's see, there are at least 4 unique digits in this. So it cannot be 7 plus 8 plus 9. So we have at least 4 unique digits. 9 is possible because, yeah. 5, well, how many 5 circles are off? You could have a 5 because there are 5 circles that are off. Anyways, on a German whisper line, you know you cannot have... Actually, let's start coloring this long German whisper line. And we're going to make it, I don't know, orange and pink. So this is orange. You know on a German whisper line, you alternate between lows and highs, right? Because 1 through 4 can only be next to a digit that's from 6 through 9. Therefore, we'll make this yellow, actually. Let's go orange and yellow. So this is yellow. Therefore, whatever this is has to be orange, right? Because it alternates again. This is yellow. Oops, not pink. This is yellow. This is orange. This is yellow. This is orange. This is yellow. This is orange, and therefore this is yellow. Okay. This is orange. These are yellow. These are yellow. This is yellow. So these are yellow. These must be orange then. Okay. We know the 5 has to be one of these 2 cells, right? Because otherwise they're where else in row 5 can it be? Can't be here, can't be any of these. It must be one of these 2 cells. Because of the German whisper constraint. Let's see. It cannot be any of these, obviously. It cannot be this. Therefore, the 5 in box 4 has to be one of those 2 cells. Oh, one thing here. We have 3 yellows in column 2. We know there's at least 1 yellow in one of these 3 cells because it alternates between red and yellow. But it cannot have 2 cells because then that would make 5 yellow cells in column 2, which only has 4 digits. So that's not allowed. So therefore, this has to be yellow, which forces these 2 to be orange. So we know the 5 then. Also, where is the 5 in column 2? It has to be one of these 2 cells. So since the 5 is one of these 2 cells, where's the 5 in box 1? It has to be one of those 3, because none of these can be 5 in column 1. And where is, okay, there we go. Where is the 5 in row 8? It cannot be any of these, cannot be any of these because they're on German whisper lines. It cannot be this one because we know the 5 in box 7 has to be one of these 2 because all of these are German whisper lines. Therefore, the only way that this can be a 5 in row 2, it has to be here. So this has to be 5 to fulfill both column 2, or column 2, yes, and row 8. Therefore, we know there are 5 5s in circles. Where can they be? They have to be, we counted them earlier. There are only 5 5s that are not on German, 5 circles that are not on German whisper lines. Therefore, it has to be in those circles. So this is a 5, this is a 5, this is a 5, and this is a 5. Which means we now know where all the 5s are. This can no longer be a 5. This can't be 5. This can't be 5. This can't be 5. This can't be 5. So therefore that's a 5. This must be a 5 here. One of these 2 is a 5, and one of these 2 is a 5. Okay. So we know we have a 5 at least. Therefore, we have at least 3 other digits that add up to either 19, or it could be 5 digits, 5 other digits, or 4 other digits that add up to 19. You cannot, well, you could have 5 digits too, adding up to 19. So it's either 3 digits adding up to 19, 4 digits adding up to 19, or 5 digits adding up to 19. And interesting. Okay. All of the circles are in one big line. Huh. What does that mean? I don't know if it means anything, actually. We know this is orange, therefore it has to be next to 2 yellows. Because those are all yellow, therefore this is orange. The last square in box 4 must be an orange then, because we have 4 yellows already. Okay. What else do we know? This has 2 of each set in this set of 4. We have already 1 of these also. Therefore, this is also a set of 1 or 2. Sorry, this has to be 1 of each set here. That didn't make any sense otherwise. Whatever color is this, it has to be surrounded by 3 digits. So it can only be 3 unique digits on the German whisper line. Therefore, it can only be 1 or 2 in 8 or 9. Same here. This is 1 or 2, 8 or 9. This has to be orange because we have all the yellows already in column 2. So this must be orange. We don't know about this. Hmm. Hmm. So again, you have at least 3 digits that add up to 19. It would have to be, if it's 3 digits, it would have to be 2, 8, and 9. Oh, but that's not possible. We have 4 digits here. Okay, so then it cannot be 3 digits adding up to 19. It's 4 digits at least that add up to 19. Um, and 3 of them are from the same set. You can never have 6, 7, and 8 be that set. So yellow always has to be low. Okay, so now we know yellow's low. So yellow's blue. And then orange has to be high, which we label as red. So one of these is red, one of these is low. Therefore, this has to be 8 or 9. Do we ever have red in a circle that's not necessarily unique? Or that has to be unique? Sorry, do we have 2 cells? From what I can see, no. Okay, so one thing is for the lows, you have to have a 4 in it, right? Because this sees 2 unique numbers, and it cannot be 4. So this is 1, 2, or 3, which means 4 has to be in the remaining low cells, and they're all circles. So 4 is definitely in a circle. So that means the other you have to have 3 other cells at least. What's the most you can have? 4 plus 2 plus 3 plus 9 is 18. So you need at least 5 cells. Can you have 1, 2, 3, 6, 7? What's the lowest for 5 different cells? You can't have 4 cells then. Because you have to have at least 2, 3, 4 in circles, and then you have to have a 9 at most. So that's 18, which means you need another one. So you always have at least 4. Well, we already knew that. No, 5 other ones, right? 1, 2, 3, 4, and 9. So can you have 1, 2, 3, 6, and 7 is the question, right? So you always have 5 unique digits. Can you have 1, 2, 3, 6, and 7? Yes. So it's either, but you have a 4 there. So it can't be 1, 2, and 3. So therefore, it does have to be 1, 2, 3, 4, and 9 to add up to, because otherwise you can't have 1, 2, 3, 4. You can't have 1, 2, 4, and then 2 high digits. That just doesn't work, right? To add up to 19. So 1, 2, 4 adds up to 7. Plus 7 is 14. Plus 6 is 20. So that's too big. So it always has to be 1, 2, 3, 4, and 9. So all the red circles are 9s. So this is a 9, this is a 9, this is a 9, this is a 9. This is a 9, 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 right? And that should be all the 9s, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we have 1, 2, 3, 4 here. So this is 1, 2, 3, or 4. These are 1, 2, 3, 4. Yeah, we just have 1, 2, 3, 4s everywhere in the low circles. Okay, so what does that mean then? This can't be 9 because of this 9. Therefore, this is an 8, which makes this 1, 2, 3, 1, 2, 3, and 1, 2, 3, because 4 can never be next to 8 on a German whisper line. Therefore, we have a 1, 2, 3 triplet now in box 4, which eliminates 1, 2, and 3 from the rest of the box. So therefore, this is the 4 here. So this can't be 4. This can't be 4. This is a 6, 7 pair, because that's all that's left in box 4. Okay. This can't be 9. It can't be 8. Therefore, this is a low. It's 1 or 2. And therefore, it must be surrounded by 3 highs. So now we have a 1, 2, 3 triplet in row 5, which means 1, 2, and 3 cannot be in the rest of the row. And since this can't be 3, the 3 must be one of these 2 cells. So therefore, this cannot be 3. It's a 1 or 2. So whatever this is has to be here. This can't be 4 because of that 4. This cannot contain a 9 because we already have a 9. Therefore, this must be 6, 7, or 8 to be high, which means this has to be next to a 6. So it cannot be 2. It has to be 1, which means this is 2 and 3. This is 2 and 3. We have a 2, 3, 2, 3 pair in box 4. Therefore, this can't be 2. This must be a 1. This has to be next to a 6 or 7. There cannot be a 1, or actually it can't be, yeah, this is 6 or 7, because those are the only highs left. This can't be 1. This can't be 1. These can't be 1. Okay. This can't be 1. This can't be 8 in either of these squares. So this is a 6, 7, 6, 7 pair in box 5. So the rest of box 5 cannot contain a 6 or 7. Therefore, this is an 8. This is now low, and this is high. Well, this can't be 4. It could be 2 or 3. This cannot be 6 anymore, and it can't be 8 or 9, so this must be a 7, which makes this a 2, which makes this a 3. This can't be 2, so it could be 3 or 4. The 6 is one of these 2, and we have another 3 or 4 here. So let's remove the coloring there. This is 6 or 7. This has to be specifically 4 and 5, because those are the only cells left. Therefore, we have a 4, 5 pair in box 6. Therefore, a 4 and a 5 cannot be in the rest of the box. Therefore, this can't be 4. Now we have a 2, 3 pair in box 6. So 2 and 3 cannot be in the rest of the box, in the rest of the cells of the box. Therefore, this is a 1. We have our only 1 in a circle then, which means 1 cannot be in any of the other circles because, as it says, a digit in a circle indicates how many circles contain that digit. We can only have 1 1 in a circle. So 1 cannot be in any of the rest of the circles. This can't be 1. These can't be 1. This can't be 2 either because the 2's in that box. Therefore, this is a 3, 4, 3, 4 pair. This can't be 3. Therefore, this is a 2. This can't be 2 then. So, let's see. We have a 3 here. We have a 3 here. So one of these must be 3 because it's a 2, 3 pair. This is a 3, and one of these must be a 3 because it's a 3, 4 pair. Therefore, we have 3 3's already in circles. Therefore, the rest of the circles cannot contain a 3. Therefore, this must be 4, and this must be 4, which means this can't be 4. This has to be 3 or 6, and this is 3 or 6. This can't be 6 because it's not next to a 1. Therefore, this must be 7, which makes that a 2, which makes that a 3. Therefore, this must be 6. This is 3 or 4. This is 2 or 3. There can never be a 9. Okay, yeah, what are the possibilities here? What's left is 1, 2, 6, and 8, right? So this is 1, 2, oops. This is in the row 8. This is 1, 2, 6, or 8, and this is 1, 2, 6, or 8. This cannot be 2 because of this 2. This can't be 1. So 2 has to be one of these 3 digits. If this is 6, this cannot be 1, and it can't be 2. So 2 would have to be next to a 6, or 8 would be next to a 6, which is not allowed. So this can't be 6 then. What's left here? This is 1, 6, and 8 also, right? So this is 1, 6, 8, 1, 6, 8, and 1, 6, 8. Again, if this is 1, this has to be 8, which means this is 2. If this is 6, this is 1, and therefore this is 6 or 8. That's fine. What's left here? This is 2, 3. This can't be 4. This can't be 4. This can't be 4. Where's the 4 in box 5? It cannot be here, cannot be here, cannot be here. Therefore, it must be here. What's left over is 8 here. So therefore, this can't be 8. Cannot be 8, and it cannot be 9. Therefore, if it's 6 or 7, it could be with 1 or 2. Or if this is 6, this has to be 1. So this is 1 or 2 here, and it's with a 6 or 7, but we're not sure which one is which. This is 2 or 3. This is 2 or 3. What's left in box 2 must be 1, 2, 7, 8, right? Yeah, that's fine. This can't be 2, though. So we have 2 lows. If it's 2 other lows, it would have to be 1 and 3, and then it would have to be with 8. If it's 2 highs, this can't be 1. So this would have to be 2. Okay, so this can't be low. If this is low, this would have to be 3 or 4. So it would have to be 3 with 8 or 9. But 9's already in that box, so therefore this cannot be low. So therefore this is high, and we're surrounded by 2 lows. So then this is low, and then this is low, which means this is 1 and 3. So this is 1 and 3 and 1 and 3. This must be at least an 8, and it can't be 9, so therefore this is an 8. This can't be the 1, 3, 1, 3 pair eliminates 1 and 3 from the rest of the row. So this can't be 3, so this is 6. This can't be 1 or 3 or 8, so therefore this is 7. Which means this can't be 7, so that forces this to be 6. This can't be 6, so this is 7. There's no 7 in the rest of the box, in box 2. Therefore, this must be 3. What else do we have? This can't be 4 because of this 4, so this must be 3, which makes that 4. This can't be 3, so that's a 2, which means that can't be 2, so this is a 3. These can no longer be 2 here. Therefore, it's a 1, 8, 1, 8 pair in box 2, which eliminates 1 and 8 from the rest of the box. So therefore, this is 2. This can't be 6, so this is 1, 8, and 1, 8. So therefore, that makes this 6. Therefore, that makes that 7, and therefore that's 6. These still work. Three cannot be any of these cells or these cells, so it must be one of these 3 cells. 2 can't be here. 2 can't be here. Where is a 2 in box 7? It has to be here. We have, what, 1, 7, and 8 left. So this is 1, 7, or 8. This is 1, 7, or 8, and this is 1, 7, or 8. That's fine. We have to have a 3 in box 1. It cannot be here, cannot be here. Therefore, it must be here. what's left here? This is 2, 4, 6, and 7. This can't be 4 or 6, so therefore this is 2 and 7, and this is 2 and 7, and these are 4 and 6. Since we have a 4, 6, 4, 6 pair in row 1, the rest of the row cannot be 4 or 6. This must be 1, 7, or 8. So where's a 7 then? This can't be 7 because of the 2, 7, 2, 7 pair here. If this were 2, it would have to be with a 7. But that would eliminate all possibilities for this cell here because it can only be 2 and 7. Therefore, this can never be a 2. Therefore, the 2 is one of these two. Therefore, this can never be 6 because if it were 6, it would have to be with a 2. And that's not possible on a German whisper line, so this cannot be 6. Therefore, we know this is a 1 over here, so this can't be 1. Therefore, we have a 2, 8, 2, 8 pair in row 8. So that eliminates 2 and 8 from the rest of the row. This can't be 8. That's 1 or 6. One of the 1s has to be here, so this can't be 1. Therefore, this is 3, which makes this 1. Therefore, this can't be 3. We have a 2 and an 8 in one of columns 6 or 7 or 8. We also have another one in one of columns 7 or 8. That means in the rest of column 7 and 8, there cannot be another 2 aside from in one of these cells or one of these cells. Therefore, this can't be a 2. That's a 7, which makes this a 2. Okay, this is 2 or 8. It could be with 8 or 1. That's fine. This has to be a 3, 5, 3, 5 pair because there's no other place for it. Now we have 4, 6, and 7 as possibilities. Oh, this can't be 8 because of this 8. Therefore, this must be a 2, which makes this an 8 next to it, which makes that a 1 because it has to be at least 5 away from 8. Therefore, this is 8. Let's see. This is 6 or 7. This is 6 or 7. This can't be 7 anymore, so this must be 6, which makes that a 7. Therefore, this must be 1 and 6 to be 5 away from each other. That makes this a 4, this a 7. This can't be 7 or 8, so this must be 1, which means this can't be 1, so this is 6, this is 1. This can't be 6, so this is 4, this is 6. This can't be 4, so then that makes that 5, 4. This can't be 5, so that's 3, and that's 5. This can't be 2, so that's a 3, and that's a 2. This can't be 1 anymore, so that's a 8. This can't be 1 or 8, so this is 7. This 8 makes that a 1. That makes that an 8. This has to be 1 then. This has to be 6, and now we're just finishing Sudoku. This is a 4, and this has to be 8. And that's a solution. Fairly straightforward if you know circles and you know German whisper lines well. A lot of people seem to have problems with circles. I find them fairly simple. And I enjoyed them, actually, quite a bit. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.